The first section is all about analyzing three-dimensional figures. They give you some examples of three-dimensional figures. We have a sphere, we have a triangular prism, we have a cone, and we have a pyramid. All right? And what you'll notice is they all have different types of faces. The sphere, you wouldn't really call it having faces, because if you were to open it out, you would see kind of different circles kind of cut a little bit. For the triangular prism, which is the next piece here, if I were to look at this, the faces, what they consider the faces are these sides that connect the two ends. So those are rectangles. And then the base, those are the figures that are congruent on top and bottom of that prism. So these would be your bases, and the faces would be considered the sides of it. For this cone, the base of this cone is this circle down here. This is the base of the cone. The cone goes up into a point. And then if you look at this last figure over here, you have a pyramid. Pyramids can have all types of bases. Pyramids and cones are almost identical, except what the base is. For a cone, the base is a circle. For a pyramid, it is any really polygon. And so in this case, we have a five-sided polygon. What is that called? What is a five-sided polygon? Yeah, a pentagon. All right, so this is called a pentagonal pyramid. Pentagonal pyramid, all right? Just name it by the base itself. Now, what you'll notice is they have different vertices. Vertices are where they get to a point. The sphere doesn't have any vertices because it has no points. But you'll notice that the other ones have points. So if I were to look at this triangular prism here, I have a point where it meets here. Over here is going to be a point. There's a point. So I have these points right there. All right. And there's actually a formula to calculate the number of faces, the number of vertices and edges of a convex are all related. They're all related. And so look at the formula right there in the middle of that page. It's called Euler's formula. The number of faces, vertices, and edges of a convex polyhedron are related by the formula V, meaning vertices, minus your edges plus your faces equals 2. So let's look at this first example here. We have a triangular prism. The triangular prism had 6 vertices, 9 edges, and 5 faces. So if I were to go back, so if you look at this, vertices, that's 1, 2, 3, 4, 5, 6. Edges. Edges are where the two sides meet each other. Not at a point, not where multiple sides meet, but where two. You have a line segment. So I have 1, 2, 3. And then I have 4, 5, 6, 7, 8, 9. I have 9 of those. And then faces. The faces here are talking about both the side faces as well as the bases. So I have 3 that make up this one, that one, and the bottom one. 3 there, and then 4 and 5. All right, and so you'll see that they all subtract and add to 2. It's a very odd pattern that you see. The triangular pyramid is going to be a triangle on the bottom. So triangular pyramid is going to be something like this. Beautiful drawing there. 4 vertices. So we have 1, 2, 3 down here, 4 up here. Edges, we have 1, 2, 3, and then 4, 5, 6 edges. And then faces, we have 3 of the faces up here, and then our base, which is another one, which is 4. And once again, the pattern is created. And so that pattern will always be the case. Vertices minus edges plus faces will always equal 2. Always equal 2. Sketch each cross section. All right, so they have taken a cone. And what they mean by cross section is if you were to cut it, what picture would you get right there if you were to cut it? So they cut it right here in the middle. You can see that is going to be a perfect little circle all the way up. Now it's going to be getting larger, right? If you cut it closer to the bottom, you have a bigger circle. The further you get to the top, you're going to have a smaller circle. But if you cut it parallel to the base, you're just going to have a perfect circle that matches the base. You'll notice that when they did a slant, it changed it a little bit. So when they did a slant, they actually got an oval, which makes sense, right? Because the closer it was to the bottom would have been larger. When it was towards the top, it would have been going in to be smaller. They cut it straight down, and they got what looks like almost a semicircle. It's actually half of what's an oval look. The base would have been a straight line because they cut it down here, and then it would have curved as it went up. And similar, it would have been like this if they cut it directly on it. So they cut this directly on the slant itself, creates almost a triangle. Now what we're going to do with these is we are going to look at what happens when you open them up. All right? What happens when you open them up? All right, so if you lay it out, you're going to get what's called the net of the figure. This is called the net. If you were to take a three-dimensional figure and just lay it out, it is the net. And then I want you to calculate the areas of the what's called lateral faces. All right, the areas of the lateral faces. These would be these right here. And then I want you to calculate the area of the bases. The bases. And then I want you to add them up and give me the area of all of it. So you should have three answers. You should have the area of these lateral faces that create going up to it. Now, if you're creating a pyramid, you're only going to have one base, because I also want you to do the bases. So if you have a prism where it has two bases, you'll have two of those. If you have a pyramid, you'll only have one base. And then I want you to add those up and give me the area of all of the figures. So I'm going to give you a ruler. All right, so for this particular one, they've given us some dimensions. They've given it to us, well, they were nice. They did inches and feet. All right, so you'll notice they laid this out, okay? And then they said, draw a net showing the dimensions. You have to think about what's going on when they give you these dimensions. Just like the three-dimensional figures that you had measurements here. And then when you lay it out, it's exactly the same. That 6 by 6, and this is also going to be a 6, right? So this is 6 by 6 by 6, which means the base of that rectangle was also 6. They said 2 feet, but we have to have it all in inches or feet, so they converted to inches, which means this length of the rectangle was 24 inches. 24 inches. And so you have to be able to visualize what's going to happen when I lay it out if I'm going to calculate this given a three-dimensional figure, because you're going to be given something like this and it's going to say calculate what it is. All right, look at the next one. Identify and then find the total areas. Okay, so when you look at this, sometimes it's hard to tell what it's going to be, but you have two things that are identical. These two rectangles here. And then you have these other guys that are rectangles, but they're not exactly the same. So when you put them together, this is going to be your top and bottom, and these are going to be your sides. And you'll see it looks somewhat like a cereal box, actually. All right, and so we have this rectangular prism. Our bases are the two things that are congruent. These are my bases right here. And then my lateral faces would be these. Now, I will say with a rectangular prism, I could turn this up on its side, and I could use these as my bases if I wanted to, because those are congruent. Or I could use those as my bases if I wanted to. All right, so when you think about what your bases and your faces are, it's possible that one person does it one way and one person does it another way. What is not ever going to be different is your surface area, or the area of the whole thing, because then you're adding up all of them. And so if I wanted to calculate the area of all of these, I would say, well, this is 6 by 2, and this is 6 by 2. So if I did that, those individually would each be 12 centimeters squared. All right. And then if I did this one on the side here, I have 2 by 8. That's 2 by 8, and that is 2 by 8. So both of those would be 16 square centimeters. And then I have two of my what they used as bases here. So I have this is going to be 6 by 8, and that is going to be 6 by 8. And so that's going to give me 48 square centimeters for each of those. So if I wanted to calculate my entire surface area, I would add up all of these. I would say, well, I have 2 48s, these two, that's 96. I have two of these 12s, that's going to be 24. And then I have two of these 16s, that's going to be 32. And if I add all of that up, all of my area for all of those figures would be 152. So think about when we did composite figures way back in area. You're basically just doing the composite of all the surface areas of these figures. So this actually looks identical to the last example, except they've just stood it up, all right? And so we have two terms here that we're going to introduce in this section. The first term they call lateral surface area. I just call lateral area, so not to confuse it. The first term that we're going to look at is lateral area. Lateral area is the area of everything except your bases, okay? So when you calculated your figures and I said, hey, I want this, and then I want you to calculate your bases, and then I want you to add them together, what you were actually doing is you were getting the lateral area when you did that, okay? And so lateral area is going to be the area of everything except your two bases. Think of it as if you have a can of soup, the label that goes on the soup itself. That would be your lateral area. It doesn't include the can's top and bottom. It just includes what goes around it, okay? That is your lateral area. I actually have the formula here. The lateral surface area of the right prism is the product of its height and the perimeter of the base. The perimeter of the base. Now let's look at what that means. So when you calculated your figure, some of you laid it out and you said, okay, I'm going to take this one and I'm going to add this one and I'm going to add this one and I'm going to add this one. All right? And you ended up with the area of your faces. Some of you laid it out and just measured all the way across because you'll notice this is a big rectangle. All right? All the way across and multiplied it times this. Well, what was that doing? This was created by the perimeter of the base. Does everybody see that? That was created by the perimeter. So if I were to take the perimeter of the space, which is A plus B plus another A over here plus another B over here, if I took all of that, that would actually give me this base right here. A plus B plus A plus B. All right, that's the perimeter of my base. And if I multiply it by the height of my prism, that's the height of that rectangle I'm trying to find. And so if I want to find the lateral area of a prism, I'm going to say perimeter times height. Now I want to point out that the height is capitalized. That height indicates the height of the prism, not the height of your base. Because what you're going to start doing is you're going to see a base and height on your actual rectangle that creates the base of the prism. And then you're going to see a height of the prism itself, all right? So for example, if I were to take this little rectangle down here, and I were to say, what's the area of that rectangle? You would say base times height, right? That's the area of a rectangle. And so if I were to draw this little tiny rectangle, I would have a base and a height of that little rectangle. They do not want you to confuse that with the height of the prism itself, the actual box. So you'll see that one is always capitalized because it indicates the distance from this rectangle all the way to that rectangle. All right, that is the height they are talking about here, not to confuse it with the height of your base itself, okay? And so your lateral area is calculated by perimeter times your height. Let's look at this. Let's look at this, all right? They want the surface area of this right triangular perimeter because that's what we're talking about. So let's talk about just lateral area. If I were to ask for the lateral area of this, I would want the area of just my faces, okay? So I need the perimeter of my base first. The lateral area is going to be perimeter times my height. You'll notice that they gave me two of them down here, 8 and 7. Your bases are going to be congruent. They gave me the third dimension, the third measurement up there. So if I wanted the perimeter of my base, my perimeter is just adding those three, 8 plus 7 plus 10. So my perimeter is 8 plus 7 plus 10. Height. They do not want the height of the triangle. See, they also gave me the height of the triangle right here. Everybody see that? I don't want that height. I want this height. I want the height of the prism itself. And so I'm going to multiply that height then is going to be 20. All right. My lateral area then, my lateral area is going to be 500 centimeters squared. I get 25 times 20. 25 here times 20 there. So my lateral area is that. Lateral area is that. Surface area, the only difference is I am now going to add in the area of my two bases, okay? So my surface area is going to take this number right here, surface area. The surface area formula is actually on page 408. I'm going to take the area that I just found, that 500, and and I'm going to add to it my two triangles, right? Because I've already calculated the faces. I've already taken into consideration these guys right here. Now I need to add in this if I want the total surface area, and I have two bases here. So now I have to remember the formula to calculate the area of a triangle, okay? So that's why those area formulas are so important. I now have to know my formula for a triangle, okay? And so I am going to calculate the area of those two triangles, all right? And so the area of my triangle here is going to be my base of the triangle, 10, times the height of the triangle, 5.6, times 1/2. Remember, triangles are 1/2, base of the triangle, 10, times height of the triangle, 5.6. How many triangles do I have? I have a top and a bottom, right? For a prism, I have 2. So then I need to multiply that guy by 2. All right, I have to multiply it by 2. All right. And so I have 1/2 base times height here. I end up getting, what, 28? My 10, yeah, and then 56. So 2 of those would be 56. All right. So 2 of those triangles are 56 centimeters squared. So I have my lateral area and I have the area of my bases. My surface area, I have to add that 500 to it. So 500 plus the 56 is going to give me 556 centimeters squared. So that's my lateral area, just my faces. My surface area, you have to add in your bases. Take your area that you already found of your lateral faces, add in your two bases. All right, add in your two bases. Cylinder, the lateral face of a cylinder is also a rectangle. But I no longer call it perimeter. For a circle, what do I call it? How do I measure around? Yeah, circumference, okay? And so it looks a little bit different. The lateral area, you see this little C instead of perimeter. It's really the same. It's perimeter times height. But for a circle, we call it circumference. There's a special formula for circumference. What's the circumference of a circle? 2 pi r. So for a cylinder, you're going to say it's going to be 2 pi r times the height. 2 pi r times the height. That is your cylinder. That is your lateral area of a cylinder. 2 pi r times height. Surface area. The surface area of a cylinder or prism is your lateral area plus 2 of your bases. Your lateral area plus 2 of your bases. Surface area of a cylinder is also your lateral area plus 2 of your bases. How do you find the area of a circle for that base? What is this going to be? If your base is a circle, what is that formula going to be for that area? Pi r squared. All right, so on your sheet, if you want to, for a circle, you can either write your lateral area plus 2 of your bases, or you can say 2 pi r, that's my 2 pi r times h, that's my lateral area if I want to plug that in. And here, you can say lateral area plus 2 pi r squared. All right, you have to remember your formula for your cylinder. So they want the surface area. We're going to do twofold because on your quizzes, I asked for 2 different things. I asked for lateral area and surface area. 2 answers, okay? So lateral area. Lateral area is going to be my circumference times the height of my prism. So how do I find the circumference here? My radius is 6. I'm going to say 2 pi times 6 times the height of my cylinder, which is 9. The height of my cylinder, which is 9. All right? So I have 2 pi r times the height of my cylinder. You calculate it. Actually, I don't think you have to round it. They left pi in the figure. That's going to be my lateral area. I have to calculate a base. My base is my circle. I already know my radius is 6. So pi r squared, or 36 times pi. So if I want to find my surface area, I'm going to take my lateral area, 108, plus 2 of my bases, 36 pi, and that will give me my surface area. So I have 108 pi plus 72 pi, all right? And that's going to give me 180 pi for my surface area. So my lateral area is 108 pi feet squared. My surface area is going to be 180 pi feet squared. If they tell you to round it, just plug the pi into your calculator and round it.